Salt is so plentiful that it's easy to take for granted. It fills our oceans and crowds our cupboards. But it's a vital element of life. So precious, in fact, that in ancient times it was traded ounce for ounce with gold. But mining salt is no easy task. It's hard and dangerous work. In this episode of Hands on History, we'll see firsthand how that's so as we go deep into a salt mine. Here, in an underground city 1,600 feet beneath the surface, I'll drive gigantic equipment and set dangerous explosives. I'll man modern machinery as I put my hands on history. Welcome to Hands on History. I'm Ron Hazelton. I'm here in the heart of Cajun country on Avery Island, Louisiana. Behind me is a mine shaft that brings salt up from 900 feet beneath the surface. Around here, another day at the salt mine isn't just an expression. It's been a way of life since the 1860s, when this island became home to the first salt mine in North America. Avery Island has produced salt since 1791, when a young boy first discovered a brine spring there. The mine was built by John Avery, principal supplier of salt for the Confederacy. Avery's workers sunk the mine to a depth of 90 feet, using little more than shovels, picks, and axes. Today, it goes a good bit deeper, 1,600 feet and counting. To get there, miners must be lowered down a shaft in a man cage. As they descend into the mine and ultimately to the 1,600-foot level, the miners entrust their safety to two individuals. The first is St. Barbara, the patron saint of miners, whose prayer is mounted at the shaft's entrance. The second is Philip Barad, the hoist operator, who lowers and raises a steady stream of people and equipment into and out of the mine. Philip's been at the mine for a long time, 36 years. But he's got nothing on the steam engine that operates the elevator. It came off a riverboat more than 140 years ago. And Philip operates it all from a pulpit just next to the shaft. He let me take the seat and gave me a lesson in hoist operations. This comes off.
Steam brake, turn off.
Okay, brake is off. This is my throttle. So what am I doing right now? Am I opening a steam valve somewhere?
Right, you're opening a valve.
Oh my gosh, listen to that.
Throttle valve.
This is incredible.
You hear
there are
the steam.
Two huge pistons out here moving back and forth. Now what makes this procedure so difficult is that the man cage is not visible from the pulpit. There's a small video screen so you can see the top of the shaft, but everything else is done by feel and judgment of the red and yellow markers on the depth dial. Kind of close to the red line there.
Right. Once you pass the red line, you have to go slower.
Even slower than I'm going now.
Oh, yeah.
You just put the brake on?
No, I just reversed it.
Reversed it. Okay.
Wow. This is at the landing.
Wow. Right on the money. Well, you helped me out. Thank you for the driving lesson, Bob. That was great. Well, now it's my turn to go into the mine. But before I do, I first had to get the proper safety gear. Now, there's a lot that can go wrong down there, so I asked Lonnie Badeau to help me get ready. He showed me the proper equipment, which includes a hard hat and lamp, steel-toed boots, and a breathing apparatus. Now, it all makes you feel safer, but the thought of having to use the breather gives me a chill. Finally, he gave me a check tag, which is hung on a board to keep track of who's in the mine at any given time. Once I was suited up and tagged out, well, it was time to go. Just like uptown, huh? I rode the man cage down to the 500-foot level, along with Randall Romero, the mine production superintendent, and Russ Gibbons, the production supervisor. You know, I'm surprised it's black. I expected it to be white, salt, that sort of.
Well, when it was mined originally, it was white. But the carbon from the diesel equipment and the explosive fumes, it will attach itself to the salt and it will turn it black.
Okay, so I would imagine as we get into newer parts of the mine, there's less
Newer
of this.
parts of the mine are going to have less.
You know, if I look up here, it seems like this is all kind of smoothed out a little bit. Is that the way they would have mined it? That's the way it would have looked?
No, when they originally mined it, it didn't look like this. The air currents coming from the exhaust air and the humidity works on it, and it kind of like erodes it.
So now we're on the 500-foot level. As I understand it, there are several levels below us.
Correct.
And how are those connected one to the next?
Well, we drive what we call declines from one level to the next. And we just, as we go down, we'll leave 200 feet of salt in between each level, and we drive down.
Driving through the mine was like driving along a giant spiral staircase. Although we went a quarter-mile deep, the drive to get there was nearly 2 miles long. We drove through giant thoroughfares cut directly into the salt formation. These are as wide as a 2-lane road, and in some places, 100 feet high. As we drove through the mine, we passed through salt deposits left over from an upwelling of seawater that evaporated millions of years ago. And along the side of the road, we came across some equipment left over by miners when this was as deep as the mine went. Wow, what is this?
This is an old shovel they used back in the early 1900s, Ron.
Looks like the Titanic.
It's an old dinosaur now. It came down here with this original wooden boom. Buckets here.
So this just stopped working at some point?
Yeah, it just stopped working, or it became obsolete, and as the mining industry progressed machinery-wise.
So what would be the modern-day equivalent of this now?
Front-end loaders that we use today.
So they all come in, but nobody leaves, huh?
Whatever comes down here doesn't leave, it stays down here.
Now, the reason for this is that to be removed, the shovel would have to be completely disassembled and taken out of the mine by way of the elevator. It's just much simpler to leave it here. In the past, the roads high up in the mine were cut by men with picks and shovels. But today, the new roads are cut by a machine called a continuous miner. So this is a miner, huh?
This is a miner, Boyce Alpine miner, 105.
Wow. And I take it this is the business end down here.
Yes, this is the cutting end, the cutting head, what we call a pineapple.
So this rotates?
This rotates, you have one set here, one set on the other side, rotates all at the same time. And you're just working in a sweeping motion, and it chips off the salt.
So we can walk up to a face of salt and just cut a tunnel right through it?
Cut a tunnel right through it.
You think I could go up on top and just take a look at the controls for this? Today, the machine is being run by Marty Menard. I was able to talk him into giving me a quick lesson as to how it works. So this is the driver's seat, huh? The power of this machine is incredible. With just a quick push or pull of the controls, Marty is able to pulverize the salt wall with a methodic precision. So you're going to go all the way to your limits on both sides and then move forward about 6 or 8 inches.
Once you're in about 2 to 2.5 feet, you're now ready to begin cutting up.
Okay. Could I try this?
Sure.
Well, the real moment of truth was when Marty let me sit in the driver's seat. So we need to go in like about 6 inches here?
Right. Gradually just push it forward. And you feel it pulling you in. Now, once you're in, then you'll use this control going right.
When you consider that the first passageways were cut with a pick and axe, you can understand why the miners appreciate the power of this machine. Awesome, awesome, it really is.
You like it?
What about a power? We've seen what a continuous miner can do, but next we'll see how to mine salt even faster and more efficiently by setting dangerous explosives directly into the salt face. Hands-on History will continue on the History Channel. Hands-on History returns on the History Channel. Welcome back to Hands-on History. I'm 1,300 feet underground in a salt mine on Avery Island, Louisiana. This salt is part of a gigantic formation called a salt dome. This one is 1.25 miles in diameter, 40,000 feet deep. That's nearly twice as deep as Mount Everest is tall. And when it was discovered in 1862, it revolutionized the industry in this country. Before then, the only way for Americans to get salt was by boiling salt water. This was done in the home or commercially at salt works, concentrated around brine springs. The most prolific of these were in and around Syracuse, New York. In fact, the salt from Syracuse was so vital that its shipment was one of the prime reasons for building the Erie Canal. But this dominance was challenged quite accidentally in 1862 when John Avery decided to expand his evaporation facilities in southern Louisiana. As he attempted to deepen one of his wells, he struck the top of the dome just 16 feet beneath the surface. It was the first record of rock salt discovered in North America. As the geology of salt became better understood, the industry moved underground. Salt deposits were discovered across the country, and conventional mining soon overshadowed the lengthy evaporation process. Although this mine dates back to the 19th century, the equipment used to work it is completely modern. Walter Lewis is manning the undercutter. Now notice how precisely he's cutting out the kerf or gap beneath the wall. This gap will help the salt face break apart during the explosion and will ultimately determine the depth of the huge salt block that will be pulverized. So how deeply are we cutting back in here?
Just about 20 feet.
About 20 feet. Using the undercutter, we've defined the face that we're about to extract from the mine. But rather than use the continuous miner to slowly clear the face, it will be removed all at once with powerful explosives. To do this, holes are drilled into the face in a precise arrangement. Then the explosives are placed into those holes with an ANFO loader. The ANFO loader is the trade name for the machine that loads the explosives directly into the holes. It allowed us to move up and down the 28-foot high face and place a total of about 100 charges. Greg Eugene showed me how to load the charges. This is a blasting cap right here?
Yeah. Shove it into the hole.
This is just a piece of rubber hose.
Right.
It's safe to handle?
Yeah. Right, yeah.
Sure.
Okay. All right, shove it into the hole.
You ever had one of these go off unexpectedly?
Sometimes it's not, you know, unless you break that cap right there.
I'll say break it.
Yeah.
Okay, well, I will try not to do that. Okay, now what? Shove it in?
Just keep shoving the holes into the back of the hole.
Now this hole is, as they said, 20 feet. And we got to go all the way to the back?
Yes, sir. Keep going to the back.
Okay.
Till it stops.
Now, if I were to ram this back there too hard, could that be a problem?
No, sir. As long as the cap in the holes is safe.
It's safe. Okay. Wow. There you go. I'm at the bottom now. That's as far as I'm going.
Okay, now. I'm going to do one and then I'm going to stop.
Do a little bit. I can watch you do it. Greg turned on the pump, which pushes the ammonium nitrate explosive through the hose to the back of the hole. So you're sort of packing this explosive in there, right?
Yep, just let it go.
And you're backing the hose out as you do it?
Yes, sir.
Do I have to hang on to this wire?
No, sir, you don't have to hang on to it.
Okay, go ahead. So it's important that this be packed in there, huh?
Pack it and pull it back.
Pack and pull it back. Pack and pull it back. If this isn't well packed, what could happen?
Oh, the only thing could happen is it's still going to go off because it's packed to the back.
But you just might not get the kind of
you're not going to
get
much penetration for your hole. That's all about it.
Yeah, I can feel it. I can feel it when it sort of fills up in there. I can't pack it much more.
Yeah, okay. You good right there.
That's it?
Yep, you good. That's it.
Now this method is much safer and more controlled than in the old days when dynamite was slipped into the holes that were manually drilled with a breast auger. The ANFO loader allows us to set a great many charges all at once. They are then connected onto a single circuit that connects to an above-ground blockhouse. The reason blasting is done at night is because any explosion carries the risk of fire or roof collapse. At the end of the second shift, I went back above ground with the miners. Once the mine was cleared and everyone had tagged out, I headed over to the blockhouse, where I met up with Russ Givens. As the production manager, it's his job to set off the explosives every night. although this night he let me have the honor.
So Russ, these two wires right here will set off everything that we hooked up down in the mine.
Yep.
Okay?
This is the final electrical connections to tie the entire blasting circuit together.
Okay. And this is what they're going to get hooked to?
Yep, this is a capacitor discharge blasting machine. It'll put out about 600 volts of electricity. It'll travel down the mine, set off the electric caps, which in turn will set the faces off in delay.
Okay, hook these up.
So the first thing we'll do is we'll hook up the wires.
Does it matter which one goes on
Doesn't
which
matter,
one?
it's
Okay.
a non-polar system.
Okay. There's one.
There's
I
one.
can't believe we're actually going to do this. How much explosive have we got down there?
We're going to be setting off about 5,000 pounds of explosives tonight.
5,000 with a push of a button.
Now we've got to first charge the capacitor. So you're going to press and hold the red charge button.
Push this one?
Press and hold that button. We're going to look for the ready to fire light come up here. Okay, we're charged up and we're ready to fire.
3, 2, 1.
Should be one more. That's it.
You heard it? You
Yep.
heard the third one?
Yep, it's a little bit farther away, but it
Okay,
was
so
in there.
describe to me what you were listening for.
You're listening for the pattern of delays in each of the faces, and then those will be separated by a much longer gap that we use to delay one face to the other. If we had all of them going off together, it would really do a lot of shaking. So
Okay, so
we're looking to spread that out a bit.
All right. Well, tomorrow morning, after the dust is cleared, we're going to go back down into the mine and see how things turned out.
We'll be right back with more Hands-On History. Hands-On History returns on the History Channel. Welcome back to Hands-On History. Last night, we set off 5,000 pounds of explosives, and in the process, dislodged 10,000 tons of salt. Now, it's time to get that salt out of the mine. The machine that's used to do it is a front-end loader. Now, consider how big it is, and then realize that to get it down here, it had to be disassembled, lowered down the shaft, and rebuilt inside the mine. It's an amazing machine, and Brian Miguez showed me how it works.
Whoa! A front-end loader. I mean, a big front-end loader.
Yes.
Okay, I need a lesson from you, obviously, here.
Okay, this is your gear shifter.
Brian gave me a quick lesson and showed me the gears and controls. I couldn't wait to push it forward and load the bucket with salt.
Okay, so we're gonna drive into this pile of salt. Just straight in?
Straight into the pile.
With some energy?
Sure, wide open.
Wide open.
Accelerator wide open. You need the power to dig that bucket of salt.
Oh, here we go. Okay, as fast as I can go, huh?
As soon as you hit the power, raise up a foot. Okay? That off. That's close enough.
Don't break anything?
No. You all right?
Woo! Man, talk about power.
Well,
Now I go to reverse.
pull it reverse.
So now I'm not going to dump this in the truck because I don't.
Okay, you can dump it on the floor if you want right here.
Did I? Okay.
Okay, stop right here.
Stop right here. You got to really have a gentle touch with this. I mean,
Yeah.
there's a lot of weight out there. How
That's
much?
right.
18 tons?
18 tons.
It's amazing to consider that when the mine was first opened, this was all done with mules and rail carts. Later, a diesel engine car pulled the carts that ran up and down along the underground thoroughfares. Today, dump trucks carry the salt to the first in a series of conveyor belts. From here, everything is automatic. The salt is broken into smaller pieces, and then it rides along a mile of underground conveyor belt until it reaches the bottom of the production shaft, which is 900 feet deep. Here, it's put into a skip loader, a giant elevator that carries it to the surface. Once it reaches the surface, the salt is sent to one of two destinations. It's either sent to the mill, where it's turned into a variety of products such as catalycs and driveway salt, or it's loaded onto a barge and carried off to distant ports. This salt is being loaded onto a barge that will hold as much as 1,700 tons that will be shipped north to be used for de-icing roads. It's an amazing amount of salt when you consider that the entire process was done by a crew of no more than 20 people in one shift, hard at work a quarter of a mile underground.
As the saying would lead you to believe, a day in the salt mines is definitely a day of hard work. But it's also an otherworldly experience. In traveling a quarter of a mile beneath the Earth's surface, I've found that both the workplace and the workers are, in every sense of the phrase, truly the salt of the earth. I'm Ron Hazelton. Thanks for watching Hands on History.